Okay, in this video, we'll solve the problems on notches. Here the problem is water flows over a rectangular weir 1 meter wide at depth 150 mm and afterwards passes through a triangular right angled weir. Take CD4 triangular and rectangular weir as 0.62 and 0.59 respectively. Find the depth over triangular notch. See, this is the given problem. Okay, for this given problems, the given data are, see here we need to observe carefully. There is a combination of rectangular notch as well as triangular notch. See here the water flows over rectangular notch. The width is 1 meter of the rectangular weir and depth is 150 mm. Afterwards passes through a triangular right angled weir. It means first water flows through rectangular notch, then the same amount of the water with the same amount of the discharge, it passes through triangular notch. Therefore, in this condition, we need to solve what is the depth over triangular notch. That is what is the capital H for triangular notch. Okay. Therefore, in the given data, the length is 1 meter. Then depth of the rectangular notch is 150 mm. That is 0.15 meter. Then coefficient of discharge for rectangular notch is 0.62 and coefficient of discharge for triangular notch is 0.59. Therefore, we know that from the derivation, discharge equation for rectangular notch, that is QR, that is Q for discharge for rectangular notch, QR is equal to 2 by 3 into CD root 2G into L H raised to 3 by 2. See, all the values are known values. Therefore, substituting all the parameters, that is 2 by 3 into 0.62 into root 2g into length is 1 meter into h is 0.15 raised to 3 by 2, we are going to get q is equal to 0.1063. This is the discharge for rectangular notch. See, for the same discharge, the same flow rate of the water flows through a triangular notch. For that condition, we need to determine what is the depth for a triangular notch. Therefore, by using the discharge equation formula for triangular notch, that is q is equal to 8 by 15 into CD into tan theta by 2 into root 2g h raised to 5 by 2. Here the discharge is same, therefore that is 0.1063, 8 by 15, and coefficient of discharge for triangular notch is 0.59 and theta is 90 degree, that is tan 90 divided by 2, tan 45 is 1 into root 2g, then h raised to 5 by 2. By simplifying this formula, we are going to get h as 0.3572. See, this is the given problem. Okay, now let's solve the next problem. Find the discharge of water flowing over rectangular notch of 2 meter length. When the constant head over notch is 300 mm, take CD is 0.60. Here the problem is based on rectangular notch. The length of the notch is given as 2 meter and head is 300 mm, that is 0.3 meter, and discharge is 0.60. Here we need to find out discharge. Therefore, we know the discharge for rectangular notch is Q is equal to 2 by 3 into CD into L root 2G into H raised to 3 by 2. Since all the values are known values, on substitution, we are going to get Q is equal to 0.582 meter cube per second. Then the third problem is the head of water over a rectangular notch is 900 centimeter and the discharge is 300 liters per second. Find the length of notch when coefficient of discharge is 0.62. Again, here also the problem is based on rectangular notch. The height or the head over the notch is given as 900 centimeter. So it is 90 centimeter. Then discharge is 300 liters per second. Then we need to find what is the length. At CD is equal to 0.62. For the rectangular notch, CD is 0.62. These are the given datas. We need to find the length. Therefore, we know that discharge Q is equal to 2 by 3 into CD into L into root 2G H raised to 3 by 2 for rectangular notch. By substituting all the values here, in the discharge is given in terms of 300 liters per second, we need to convert that into meter cube per second by dividing 1000. Therefore, it becomes 0.3. Therefore, 0.3 is equal to 2 by 3 into 0.62 into L, that we need to find, into root 2G into 0.9 raised to 3 by 2. Therefore, at the end we are going to get L as 0.192 meter. That is, the length of notch is 0.192 meter. Okay, let's solve the next problem on the notches. That is, a rectangular channel 2 meter wide has discharge 250 liters per second, which is measured by a right angled V notch. Find the position of apex of the notch from the bed of the channel. If maximum depth of water is not exceed 1.3 meter, take CD is equal to 0.62. See here, the problem is based on V notch or triangular notch. See here, it is clearly mentioned it is a rectangular channel. Okay, therefore width of the rectangular channel, that is L, is equal to 2 meter. Then discharge is given as 250 liters per second, that is 0.25 meter cube per second. And depth of water in channel, that is the depth of water in channel means that is 1.3 meter, that is capital H. It means capital H means the depth from the base of that V notch to free surface of water, that is 1.3 meter. That is the total depth of water in channel. Then here we need to find height of water over the notch. Therefore, and to find position of apex of V notch from the bed. What is the position of that V notch from the bed, that is from the base to apex? What is that apex height we need to position, we need to find out. Therefore, we know that for the V notch, discharge equation is equal to Q is equal to 8 by 15 into CD into root of 2G into tan theta by 2 into H raised to 5 by 2. Substituting the values of Q, CD, we are going to get H value as 0.493 meter. See, it is a depth of water. Therefore, to find the apex from the notch from the bed, that can be calculated by total depth of water in channel. Okay, that is the total depth of the water in channel is 1.3 meter. Then height of water above the V notch, that is 0.493, that is calculated by the discharge equation of that V notch. Therefore, the position of apex is 0.807 meter. Thank you.